So you have a p-value. Now what? In this video, we're going to walk through three situations where we have a p-value and we need to interpret it. So here's the first one. You are told that 50% of all college freshmen engage in binge drinking, and you want to determine if this claim is actually true. Maybe this claim came from a newspaper article or something like that. You gather a random sample of 72 college freshmen at your college, so you're gathering from the proper population, and ask them questions about binge drinking. So you find that 48 people in the survey, that's 67%, engage in binge drinking. Now clearly, you found more than 50%. That does not mean that this 67% applies to all college freshmen. That just means your sample happened to have 67%. The p-value here gives you the likelihood of finding your sample, assuming that this 50% was true. So what's it mean in this case? If 50% of college freshmen at your college actually engaged in binge drinking, so in other words, if the advertised claim was true, then there's a 0.23% chance, so that's the probability, of finding a sample like ours, like the one that you gathered. In other words, you can conclude that more than 50% of students at your college are engaging in binge drinking. So let's look at another one. You measure the mass of random samples of two species of mice, and you want to know if the masses of the species are actually different from each other. So you just want to know if there's a difference between them. For species A, you measure 35 mice and find some basic summary statistics, an average mass and a standard deviation. Remember that standard deviation is how much spread there was in that small sample. For species B, you measure 38 mice. Notice it's a different number, it doesn't matter. And find, again, descriptive information like the average mass and the standard deviation. Now again, you see that the averages are different from each other, but they also have a spread for each one of the samples that you gathered. We want to know if the masses are truly equal to each other, and what we're seeing this difference here is maybe just random chance. So the p-value that we find is 0.22. What's that mean? Well, what that means is there's a 22% chance of finding the difference that we got, assuming that the masses were actually equal to each other. Well, that's not that rare, so we really don't have evidence to refute the fact that the masses are the same. In other words, they're probably the same. We don't have evidence against that. Be careful here, though. We literally found two different means, but since our p-value is not less than 5%, we are saying, well, we don't have evidence that these are too different from each other. All right, let's look at one more. A cereal company advertises that the average box of cereal contains 17 ounces of cereal. Quality control workers at the factory randomly sample 223 boxes produced in a given day and weigh the contents. The average weight of the sampled boxes is 16.3 ounces. Now again, notice that is different than what they're claiming is probably going to happen, with a standard deviation of 0.4 ounces. The sample gives us a p-value of 0.001. Well, that's actually some statistical test gives us this p-value. Now, notice they didn't actually give you the p-value. They just said it's smaller than 0.001. This happens fairly often. What's that mean? Well, if the machines are running correctly and the boxes were actually filled with 17 ounces of cereal, then the chance of us finding our sample, our 16.3 average with a standard deviation of 0.4, is less than 0.1%. We're simply not that lucky. So we conclude that the boxes are being underfilled.